Good morning everyone. Myself Shree Praveen Jee, PGT Physics. Now today we will discuss about the electrical capacitance. That is the measuring of storing ability of the charge of a conductor. Electrical capacitance of a conductor is related to its ability to store the electric charge. Means the conductor, how much it will store, means measured value of the charge storing ability of a conductor is known as capacitance. Now we will discuss or deal how it is so. Now let's see, we have something here as a one container, and that container contains liquid up to the 4 liter. It contains liquid up to 4 liter. Now here it is of the size of 4 centimeter. Gradually whenever we put the liquid here, the liquid will rise and it will rise up to the 4 liter, and after that if we will provide the liquid here, that liquid will leak and flow to the surroundings or will move outward. So what we observe here, that this beaker contains only the liquid up to the 4 liter. Now the capacitance, that is the mechanical analog of this particular. Whenever we bring the charge from infinity to the capacitor, that means we are doing the work, and that work will provide the potential to that of the capacitor. So let's suppose the charge comes from infinity, that means it need work to move from infinity to the capacitor, will rise the potential of the plate, potential of the conductor. Further again, if we further allow the charge to come here, we will find that the potential of this plate or the conductor will be the maximum. Now if we provide the further charge, that charge will leak to the surroundings and there is no storing ability. That means that conductor acquire the maximum potential up to what it has the charge Q. If we further provide, again and again I am telling you, if we provide the charge again here, on that case the charge will move to the surrounding or ionize the surrounding here. So that is not the storing ability of the conductor. Now see another relation I have here. That means here if we observe, we will find that the charge, that potential is directly proportional to that of the charge. It is not so. That means every conductor has the ability, has the maximum potential up to which it will acquire the charge. How can we understand? So on that case, we consider the two beakers, two containers of the same height 4 centimeter, but the one is a broader face. On that case, the earlier one, which is similar to that of the previous earlier one, that means the beaker number 1, it contains the 4 liter only. If we provide the further liquid, it will flow outward. But what we observe here, that it gains the maximum pressure because the pressure is directly proportional to the height h. Again here, if we provide the 4 liter, let's suppose it contains up to the 2 centimeter only of this one. So here the pressure reduced. To increase the same pressure, to maintain the same pressure, that is of the h height. So on that case, if we further put this one and suppose that beaker 2 contains the liquid up to the 8 liter, to gain the same potential, and that is the P is equal to HOG. What we observe in this particular character, that the beaker 2 has the more ability to store, and that will have more ability for what? To gain the maximum value of the pressure, to maintain the pressure. That means in both, if we see the two examples, we come to the conclusion that the container which acquired the maximum pressure, but the dimension of the container, that depends how much it will store the liquid on it. Now, similarly, that in case of the conductor also, it is the analog of this particular, that the storing ability depends upon the shape and size or dimension of the conductor. Now, here we will conclude all this, that the charge storing Q is directly proportional to the potential. The potential of these two are different. The pressure is the same, but the storing ability are the different. Now, here we cannot say that the potential or the charge is directly proportional to each other. No, it is the wrong statement. Here we will find that the potential charge is directly proportional to potential. That means the storing ability, that is the charge, the conductor acquire the charge. That is equation, or we can write here this one, Q is equal to CV, where C is that becomes the equation number 1. Let it be the equation number or relation number 1. So where C is the constant of proportionality called electrical capacitance of a conductor. Or now the equation 1 may be written as, now the equation 1 may be written as that is C is equal to Q by V. Now this is the equation, relation number 2. We come to the conclusion that here the electrical capacitance of a conductor may be defined as electrical capacitance of a conductor may be defined as the ratio of the charge stored, ratio of the charge to it to the potential due to that charge. So capacitance may be defined as the ratio of the charge to it, to the conductor, to it, to the potential due to that charge. Now, what factors on which the capacitance depend? Here we come to the factor also. The first factor is the dimension, means shape and size of the conductor. That capacitance depend upon that particular, means the dimension of the conductor is the important point for the capacitance. Next, second point is that the conductor is placed in a which medium, permeability of that particular medium. So second point, and third point is any other conductor is nearby to it. That also the factor for capacitance. So three factors we observe here, and these three factors are as factors for the electrical capacitance. Factors for electrical capacitance. First, that is the shape and size of the conductor. Shape and size of the conductor. That means the dimension of the conductor. Dimension of the conductor. Second one, that is the conductor. Capacitance of the conductor does not depend upon the nature of the material. It depends on the medium at which the conductor is placed. The capacitance of a conductor does not depend on the nature of the material. It depends on the medium in which the conductor is, the medium in which the conductor is lying. Placed. And third is the presence of other conductor in neighborhood. The presence of other conductor in neighborhood. So three factors responsible for the capacitance of a conductor, that is the shape and size of the conductor, that is the dimension of the conductor. The capacitance does not depend upon the nature of the material, it depends upon the medium in which the conductor placed, that is permittivity of the medium. Permittivity of the medium. And third is the presence of other conductor in neighborhood. Three factors are responsible for the electrical capacitance in a conductor. Now, unit of capacitance, electrical capacitance. Here, we honor the scientist named as Michael Farad. That the unit is named on that particular person known as Michael Farad. So, the electrical capacitance has the unit as a farad. So, 1 farad is equal to 1 coulomb charge by the 1 potential voltage or volt. That means 1 farad, that F is equal to 1 coulomb per volt, or it may be written as in the another way, that is the 1 coulomb by volt is the joule per coulomb, that is the joule per coulomb, 1 joule per coulomb, that is again it is written as 1 coulomb square by the joule. That means 1 farad is also represented as 1 joule, 1 coulomb square joule. Now dimension of the electrical capacitance. Dimension of electrical capacitance. For dimension 1 farad, that is equal to, now we will write here the coulomb and joule. That means coulomb square, 1 coulomb square to the joule, and the dimension of these two, that is the coulomb charge has the dimension of 80 square, while here is the L square T minus 2. That is joule energy, dimension of the energy. So on that case, 1 farad, dimension of this one, 1 farad is equal to minus 1 L minus L, here it is A square and T to the power 4. That becomes the dimension of the farad. Now, it is the very large amount electrical, that is the unit is the very large. So on that case, we use the small unit of the electrical capacitance, or commercial, or we can say that practical unit of the electrical capacitance. Practical unit for electrical capacitance. Now here, electrical capacitance, practical unit, that is the microfarad, 1 microfarad, that equal to 10 to the power minus 6 farad. Or we may have some other character also, other small unit also, that is of the 1 microfarad, that is equal to 10 to the power minus 12 farad, or we can write as a 1 picofarad. These are the smaller unit. Now next day we will discuss the next topic, capacitance, further in the next day. So thank you.